this question, we need to find out the shortest distance from all the buildings. So we are given a 2D grid where number 1 represents a building, 0 represents vacant place, and 2 represents an obstacle. And we are also given that we cannot pass through a building, we cannot pass through an obstacle. And we want to build a house at empty place. And we can select any vacant place to build our house. Only condition is that it needs to be shortest distance from all the buildings. So when we talk about shortest distance, BFS comes in our mind. One way to perform BFS that from the buildings themselves we start the BFS. For example, if we start from this building, then the distance it will cover will be this. Then from this building and then from this building, if we start BFS and summing up the values, then it will look something like this. So now from all these vacant places who are having sum of all 3 buildings will be candidate for answer. Like here only one building can reach this point because of the blocker and the building itself. We won't consider these points. So only the points who are having sum of all 3 buildings will be candidate. And among them the smallest answer will be the answer. In this case the answer will be 9. Overall it will become n square multiplied by m square because number of buildings can also be covered in whole space. One more thing I want to add is generally in this type of question we do the BFS at the source points in the queue all at once and then we process it. Then we process them using single queue instead of having separate BFS. But here we can't do that because then there won't be any way to find out that which building has reached this point or not. Otherwise our space complexity will increase. So it's better that we do that BFS of each building separately.